Right. So we ran into problems with inheritance. We kind of finagled our way out of it by declaring a private function, and certainly that is a valid solution around this conundrum. But going even further, right, perhaps we might go to the extreme of saying, no, I'm not even going to allow inheritance, right? Or I'm only going to allow it in a very limited sense, meaning the default implementation or my default stance is that I won't allow inheritance as opposed to just allowing willy-nilly, right? Here the default is that I can always inherit, right? Any class by default I can just inherit it unless I specifically forbid it, right? What we're going to do here is we're going to flip that around, that notion of saying no. I'm going to by default disallow inheritance and only allow it in very limited sense. Okay, so we're gonna flip that notion and say we're going to prohibit extensions by default, right? And only when we all agree as a team in our development team, in our design team, it says, oh yeah, well here inheritance makes sense, yes, but we're not just going to willy-nilly by default just allow it, right? Because we know we're going to run into issues. It might break certain other principles, yes, and only when we are willing to, when we know what we're doing. And we're willing to make sure that we do it right, then we will allow the inheritance, but not as a default stance, right? Because we know that just allowing inheritance is going to allow information to leak out, right? Just like we have inset 1 and inset 2, right? Some data representation, internal workings from our first implementation leaked out into the second implementation. Yes. We want to be able to have control over that. So we're going to just make the class final. We're going to say, no, we're not going to allow inheritance. So by default, instead of the default is being allowing inheritance, we're going to always remember, right, to make it final class. The class will be final, right, and we won't allow inheritance. So how do we do this? We still want to do it. We still want to reuse, right? We still don't want to have to reinvent everything, yes? We know that we have a parent class that already has all this behavior. I don't want to have to rebuild this. I still want the reusability, but without the inheritance, right? So the alternative is composition, right? We're going to use a different technique here. We're going to the implementation of our inset. Notice that we put a final in front of it, right? Meaning we cannot inherit. So how do we go around this? Well, this base implementation is imposing the fact that subclasses are no longer allowed, right? That subclasses are not going to be able to override anything, right? So the only thing that we're left with is that we're going to have to instantiate this base class, create an instance of it, keep track of a reference to it. And then all our methods are going to have to forward, right, all the method invocation to this parent class, which is no longer a parent, right? It's no longer a parent, right? We're using it as a composition instance, right? So this is a UML diagram illustrating this fact, right? Where we have a delegate interface, and we have a particular implementation of that interface, and whenever we want to use it, we're going to have a particular instance of that delegate, and all our methods are going to forward their invocations down to the delegate, right? Who actually has the implementation of the methods, right? So our methods are going to be written in terms of the delegate method, right? So we just have to forward all our arguments, all our parameters down to the delegate, right? So let's look at an example. Here we have instrumented inset 4. Notice that it's not inheriting from inset 4, right? So instrumented inset 4 is not inheritance from inset 4, which has all the implementation of add all, member, and remove, and all those, right? Instead, right? Notice that it has an instance of inset. See that? Has an instance of inset, which in this particular case, the implementation is inset 4, right? We have the get add count, and all our implementations. Okay, here's some constructor. Sorry, some constructors of initializing. Our default implementation is int set4, or you can pass in whatever implementation you want as an argument. So notice that all our implementation, all our methods are just going to forward, right? They're going to say, okay, well, I'm not going to re-implement add. I'm not going to re-implement at all, right? My delegate already implements that, right? I'm not going to reinvent the wheel, okay? So instead, I'm going to forward all my invocations down to the delegate. They do whatever they have to do, and then I just add a little bitty teeny bit to it, right? It says, okay, well, my version, after having done that, does this little bit more, right? Adds to the count. Same thing with the add all, right? It adds to the add count. Notice there's no inheritance. The flow of information is very clear, right? There's no going to the parent and the parent coming down to the child, right? There's no plumbing here. The line of execution is trivial, and this is a completely sensible solution. The only thing that is inconvenient is when you come to the methods that you're not redefining these methods. When you come to remove and to member, right? They're identical. I'm not doing anything with it, right? Back where I was inheriting, I was blindly inheriting these folks, yes, and I was just using my parents' version. Here, because I'm not inheriting, I have to re-implement them, right? I have to forward every single method, even the ones that I'm not overriding, right? So that's very inconvenient, right? So that's the small price to pay for this particular design pattern, right? That you're not inheriting anything, right? That even the ones that you're not overriding, you're going to have to forward them also to their delegate, and so it's a compromise, right? It's a compromise of clarity of execution, right, versus the perils of inheritance, right? Yeah, it's inconvenient. You have to stub out every single method, right? Even the ones that you would have inherited blindly. And one good thing is that you can receive in your constructor any version of implementation. Right? You don't care if if you're using a linked list or an array or a hash table or whatever. I don't care. Right? I'll just use the delegate. Yes. And however that is implemented. Right? However that is implemented. Since you notice our constructor is indeed accepting. Right? Notice that it's accepting inset. Right? And that inset could be implemented by any class that you pass in. Now, by default, it's using inset4 if you don't tell it which one. Right? But you can tell it by passing through the constructor. That's it. So that's all I have for you. All right. Awesome.